Hello, good afternoon, everyone. My name is Vineet, and today I'll be conducting this session on designing a distributed cache.
How do we scale? This is going to be pretty much what you all saw in your foundational videos. Actually, before I proceed, looks like, okay, there's a question from Anusha. So the basic assumption is we are replicating the cache. We will talk about that. So when we are talking about scaling, so these are usually the two things that or two ways to scale, right? One is sharding and another one is replication. Well, let's look at both of them independently because they serve different purpose. Like they are not, you you can't say that I will either have sharding or replication. They serve specific use cases and specific purposes. And here we will discuss why we may need to shard and why we may need to replicate as well. So what is sharding is basically if you have large amount of data, if you have, let's say, 200 gigabytes of memory or 200 gigabytes of data you want to cache, that's not going to fit in one server. So you will have, if you have 64 gigabyte RAM on a machine, then you will spread that across 3 or 4 different machines. So how will you do that? Like, again, consistent hashing is one of the ways. Redis actually does not do that. They have something similar to consistent hashing, but slightly different in that they basically, for every key, they calculate a number from that key and then see that they have 16K slots and then see that, okay, how many servers do I have? If they have 5 different servers, they will separate the slot space for those 5 different servers, and then they'll see, okay, where does this key belong? So if it belongs in this slot, they will put it in that server. Very similar to consistent hashing, but slightly different. And if you need to add another host, sorry, let me take a step back. You don't need to know what Redis does. Like, okay, either this discussion or your interview is not going to be about Redis. It's going to be about how will you shard. So consistent hashing is definitely an acceptable answer, and I think that's one of the most standard practices as well. So as long as you know consistent hashing, I think you are good. Basically, you are distributing the data set among different nodes. But now the in other problems, in like breadth oriented problems, it might be enough to just say that and move on because you have many other things to discuss. Whereas here, because there's not that many things to discuss, there is a chance that interviewer will ask then, okay, how are you deciding where to get the data from? Like, whose responsibility is that? So that we could again do different ways. Like there are different pros and cons to approaches. Like one, having a central router or some central proxy. So your clients will always connect to that central router. The router will know which keys are distributed on which shards, and then it'll route the traffic appropriately. Now, that could become a single point of failure. So you could now scale the router itself. So the client can know, okay, these are 2 or 3 different endpoints of the router. There could be a load balancer which is balancing between them. Or for simplicity, you can just assume that, okay, there is one router. If the router, all it is doing is just mapping that for this key go here, for that key go there, then it can actually handle significantly high throughput because it's all happening in memory. Router will need some information from somewhere to say, okay, which key belongs to which server, but that could be a configuration that could be cached in the router itself. So that you don't have to send the request every single time, but you can decide those and then periodically maybe refresh that or handle other ways. Like when the configuration changes, send a signal to the router to update its mapping, etc. That could be one approach. So the client only needs to talk to the router, but that's a centralized approach. The problem is router scalability and then single point of failure, etc. The decentralized approach could be the client can know all the servers that are there in the cache. The user does not need to know, but the client knows, and user does not, because user is importing the client library then could talk to some configuration service like Zookeeper to get the mapping of all the servers, and then the client decides that, okay, I'm going to send a request to this server or that server. But that makes the client thick. So I would not recommend that. Thick meaning that having a lot of business logic. You could still make it decentralized and simplify a little bit on the client side. So instead of knowing which key belongs where, client will just know which all servers are there, and it will just randomly send requests to either of the servers. The servers will have to have some kind of mapping to say, do I have the key or somebody else, and then route the request appropriately. So that way there is a separation of that. So the clients are a little more thick in that, like, they are not just talking to one proxy, they have 3 or 4 different, or how many other servers you may have, those connections. But client doesn't need any intelligent logic to see which server to talk to. It just sends a request to anybody, but then server now talks to some configuration service and decide, do I have the key? If not, then where do I need to send this or forward this request to? So again, pros and cons over there. In this way, it's decentralized, so you don't have a single point of failure. But you may have that additional complexity of, okay, client needing to know which all servers to talk to, and then servers needing to know, if I don't have the key, who has the key. And then, as we will see later in the slide, interviewer could also get into the failure scenarios, like what if this server goes down, then what happens? So in that case, you'll have to explain about what different techniques you could use, but those are pretty standard, right? They could either have the primary secondary approach, like hot, meaning both are there, or and then if one goes down, the replica becomes the primary, so on and so forth. So those are nothing specific to distributed cache itself. For any distributed system, you will have that those problems similar to what we are talking about right now. It is not specific to cache. Knowing the need to shard the data and then where to get the data from, these are common distributed system related problems. This is different from replication. Vishal has a question. I didn't understand the difference between 1B and 2 in persistent store. All right, so 1B is data is written to disk at a fixed, okay, I think the wording is little bad. Sorry about that. What I mean by data is same thing as 1A. So every write is written to disk, but instead of every write, writing that write to the disk every single time, we are holding that like a bunch of writes in some buffer, and either periodically we are just writing those writes only in that append only log. The second one is not just writing those, like buffering and writing those writes. It is creating a separate process and taking the entire snapshot of the state of the cache at that time. So that is the main difference. You are copying the entire snapshot state in the second one, whereas in the first one, you are kind of buffering the writes and then periodically flushing those writes in the append only log. All right, I am assuming that people are back. Okay, looks like another question. Bhavesh Kumar is asking how to take entire snapshot of cache. So when you fork a process, like it creates an entire a separate process with some shared data. So that way, even if the first process, now those are completely separate images of memory. So whatever you do in the first one will not be seen by the second one. So that is one way. Second option, I mean, there are other multiple options. Like you can create a separate thread and just go through the cache, but then you're not having a snapshot. You can kind of writing as you see. Okay, Nikhil, looks like you have a question.
No, sorry, you asked us to raise hands when you're back.
Oh, okay, sorry, no problem. Fine. Anusha, did you also raise the hand for that, or do you have a question?
Yeah, even I raised the hand for that.
Okay, sorry. All right, I think we'll just proceed now. Okay, so we talked about sharding. Let's talk about replication. So replication is different from sharding. Like sharding, again, you are placing different data in different servers. In replication, you are placing the same data in different servers. And that is mainly to preserve that data. Like in case this server is down, like you have some other server with the same data in it. Otherwise, if you have persistent enabled, then you'll have to load that from either those files or from the snapshot. Whereas if you have some other replicated data handy, then you can just divert your traffic over there. And then the second is to lessen the load on the server. So if you have multiple replicas, for read request, you can divert that into multiple read replicas. Or if you don't have the primary secondary architecture, you can do read writes anywhere. But then that creates more complexities about how do we resolve conflicts, etc. So here, basically, again, like what we are doing is copying the data on multiple read replicas. All we can choose whichever option you want. One of the simpler one is all writes go through the primary, and when the primary updates, then it can send that notification and the update to all other replicas. And you can have two options, like depending on whether you want a blocking or non-blocking. So if you want a stronger consistency, you are not sending the ACK back until the data gets replicated across all the replicas. Or if you don't care about strong consistency, then you can, as soon as the primary is done with updating its data, it can send a request acknowledgement back, and then eventually the replicas will get updated with the latest value. So discuss with the interviewer like what model you are going with, what you need to do if you want strong consistency versus eventual consistency. If you're talking about strong consistency, there is a chance they may ask about, okay, what algorithms or ways that you are familiar with. So usually two-phase commit, paxos are some of those things. But in my experience, like I don't think a lot of caching solutions are used for strong consistency model. That is mainly applicable for databases, but everything has some kind of application somewhere. So eventual consistency, you can assume that, okay, I'm okay with eventual consistency. What I'm getting is speed for that. In that case, you don't have to explain those. And yeah, I think just explain pros and cons and trade-offs of why are you're picking this and what are you sacrificing for that. So this was a different use case than sharding. You could combine those together. So you can have multiple shards, and you can then every node in that shard could have its replicas as well. So that kind of scales really well, because now you are not just limited by how much data you can store, but you can also, if you have throughput which is significantly higher on all those nodes, then you can, the read replicas could help you in distributing the throughput, and then the sharding could help you in distributing the data itself. So how do you kind of combine those together? So now here, after discussing all these things, you can kind of put all these things together in a diagram, which doesn't look like the first one where there was just one box. So simplistically, what you can do is you can just say, okay, I have some client which talks to, if you assume that there is some central proxy or router, then the client only talks to that. And then this talks to some sharded, so let's call them M1, M2, M3. These are the master nodes or primary nodes. Let's not use master slave, use primary, secondary. And then they can have their own replicas as well. So this is R11, R12. This can have R21, R22. Same thing here. R31, R32. So these are our primary nodes, and these are our replicas. So you are combining the sharding and replication here. So here in this case, if you're using centralized approach, then your router will need to know where to divert the data. If you don't use a centralized router, then these individual nodes will have to, if you are going with the decentralized approach, then they will need to know where to divert the data. So this, I don't want to say this is the right diagram, but this is one of the ways where you could draw your elaborated cache diagram to say this is the client. So client will be embedded in the user's application. So you can say user app. So client is not a separate process as such, but some library in that which is aware of what host to talk to for cache operations. All right. Any questions so far? Okay. And then again, like this diagram that we saw, like this is not specific to the distributed cache. It is applicable for any distributed systems where you have sharding and replication. So whatever you have learned in your foundational videos, you can apply the same thing. Okay, Pramod is asking, what is router? Is it listener or load balancer? Yeah, router, load balancer. You can call it load balancer, but it's not just balancing load. The reason I called it router because it is not just randomly selecting any servers, right? It needs to know where to route the request based on Actually, in that case, we can say that this needs to talk to something like Zookeeper. It will know where to route the request to. So depending on the key, it will know what is the mapping, which primary machines to go to, or if you are in that you can have, okay, depending on these replica, how am I sending to the write should always go to primary, and the reads, the router could decide to either do round robin or anything to send it to replicas. So that's why I didn't call it just a load balancer. It could act as a load balancer between the primary and secondary, but as a router to route the request to the appropriate shard. Anusha is asking, what is the decentralized approach? In the decentralized approach, what I meant was you could have a client, and so this is again the user app. So it can, again, there could be two different options. One is, let's say you have these different shards, right? Primary 1, primary 2, primary 3. This always talks to one of the servers, and then this server knows how to route the request. Or, but that is again kind of centralized, but we don't have the proxy in between. Or the client has information about what all primary servers are there. It doesn't need to know which key belongs to which server. It just knows that, okay, there are 3 servers, so I could send my request to any one of them. So in that case, these servers will have some kind of proxy or router on them, which will decide that I got a request for this key. Do I have this key, or do I need to route it to? So if, let's say, this has keys 0 to, let's say if you have only 10 keys, right, or only 9 keys, this has 0 to 3, this has 4 to 6, and this has 7 to 9. So if the request for key 0 comes to P1, P1 can handle it itself. But if the P1 gets a request for 4, this will need to have some component. They can also talk to Zookeeper, let's call it Zeki, to kind of know which keys are mapped to which servers, and then redirect that request to that particular node. So that this way, like, there is no one centralized proxy or router. Every node has information about where to route the request to. This was the decentralized approach that I was talking about. Okay, Hema is asking, what are the typical latencies in distributed cache? At the end, we will look at the benchmarks. It is a little difficult to give the exact answer because that depends on a lot of factors, but we will look at those factors. Ashok, do you have a question?
Yes, so I just wanted to know, since distributed cache is such a common requirement for so many systems, so is there any third-party solution available for router kind of functionality, or it has to be built?
So like many times the cache solution themselves will offer the functionality out of the box. So like Redis offers Redis clusters, which is basically the sharding, and then it also has replication. But the user of Redis does not need to know about what are they picking, right? They can actually hold on. Where is my window? Okay. Let me move this bar aside. Yeah, if you see the Redis documentation, I have these links on the last slide, so you don't have to remember all these links. So here you can select what option do you want. Like, this is the only single proxy that is bound to database, all connect to all master shards, etc. So user can select. So Redis kind of offers this out of the box. You don't have to worry about that, but you can select depending on, again, like Redis does this, Memcache not necessarily. So depending on which solution you are going for or going forward with, you can either, you may need to do something, or the solution may offer that, and you don't have to worry about it.
Okay, proxy policies are same as something similar to router.
Yeah, proxy here is acting like a router.
Okay, thank you.
Welcome. Okay. I think Pramod, I just answered your question. Are there ready-made tools to act as a router? That's something we'll have to custom build based on our project requirement. So it depends on what you mean by project requirement. For interview, you can't use Redis, right? Because that is a distributed cache. You can't say, oh, I'm using Redis. Then what are you building? So in that, you can say that, okay, I need these components. But then in real life, when you're using Redis yourself, you don't have to worry about these components. Redis will offer it out of the box, or any other solution. If you're going with that, they may offer it out of the box. For interview, you can't say that, okay, I'm using Redis, so it'll take care of everything. That's the difference. Okay. Okay, moving on. So far, so good. High level distributed system thing. What other things the interviewer could ask for? Like one of the requirements was performance. Like, how do we make sure that we are having high performance? So in that case, like one typical thing that they kind of care about is, are you aware of what protocol are you using? Are you using TCP or something else, and or some application level protocol? What is better and why, etc. Or UDP, multicast, all those things have how they impact that. Like if you're using UDP, then how are you making sure that the packets are not lost? So typically TCP is pretty good for fast performance between the client and server, or between the cache servers itself. Failure scenarios we already talked about, like what happens when a server fails, how do you detect failures? So you'll need some monitoring system. Actually, that is something that you could also add here, or you can say, okay, Zookeeper will also take care of that. Redis will do it again out of the box for you. So when you are offered any kind of managed solution, you will know that, or you can assume certain things, or you can check whether that solution offers you some of those things. So, but failure detection, if you are building the system, it is important to mention that okay, these systems could go down, and we will need to have some components. Again, nothing specific to distributed cache itself. Any distributed systems, you will have to worry about these things. So mentioning that proactively would get you some brownie points. Data consistency. This is actually pretty interesting and cool stuff. I think I have some reference, but check out the reference, like the CRDT versus last write wins. So last write wins usually means that, okay, if there are databases in different geographical locations, let's say whatever, US and Europe, and both are accepting writes, then whoever wrote last wins. And that can create some issues, such as, let's say you're adding something in the cart. So let's say in US, you added laptop in the cart, and then something happened to that server, and then the region failed over to Europe, and the data did not get replicated over there. And then you are adding something, monitor, to the cart, and then by that time US was back up, and then you don't have the laptop in your cart, right? Because that never got propagated. And if you're going with last write wins, the only thing that you had in the cart from the Europe was the monitor. So that it can create some issues like that. However, if you look at CRDTs, they are basically conflict-free replicated data types. They offer there is something like interesting terminology, like so we'll say it is strongly consistent or eventually consistent, but there is also a hybrid approach where we say strongly eventual, strong eventual consistency. What that means is that your data, you won't have super strong consistency, but eventually you will not lose any data. So what they basically do in that, instead of setting a particular thing, they offer operations which are idempotent and which are cumulative. So instead of just setting a particular, let's say a like counter, right? Instead of setting a value of the counter, if you just increment that counter, then the increment operation, and then you accumulate those increments at some eventual time, and it will give you the exact same, basically the right state of that particular whatever application that you're using. So like, for example, like this is an example here, right? You at T1, like you had this particular machine which incremented K1, then you did a sync between both machines, and then so at that time you'll have both as one. Then at some point you increment something else, even if there is a failure over here, like whenever they are back, because you're just incrementing the counter, it is going to eventually get to the state 2. Nothing is going to get lost. If this was, instead of increment, if it was setting the value, then because unless the first value got propagated, whenever the second person sets the value, it will kind of lose that, right? But of course, it has its limitations, like depending on if you have to set the value, then you can't really use CRDT because you are setting the value. How that is going to be cumulative. But increment or adding to set, these values could be cumulative and idempotent, so that CRDTs could be pretty useful in that. I think I may have, yeah, even in Redis, the inter-cluster replication, I may have this link as well later. We'll kind of show you that how you could achieve this with CRDT. Otherwise, just search for CRDT in Wikipedia, and it will be, you will see how that is used. Like the simple example for the likes, even incrementing, and it doesn't have to be just increment, right? Even for decrement, you could use a similar technique. Instead of subtracting the value, they are just having two separate counters, like one for increment action, and then the second counter is also increment, but for kind of thumbs, not exactly thumbs down, but if you are removing your like, right? And then when you are actually getting the value, you are saying, okay, what is the sum of the first one, which is the increment part, and then what is the, subtract that from the decrement one. So because you're adding both values, like you don't have to worry about which got there first. Ultimately, whenever they get these cumulative updates, like they will eventually be consistent across the board. So that is also something I don't know whether the India will expect you to know, but mentioning that, like how you could use CRDTs to achieve that strong eventual consistency could also get you some good brownie points. Lastly, somebody asked about performance, right? So I think I have a page or that too. I can't give you one number, right? Because the performance will depend on so many different factors. So I have included this link where for Redis benchmarks. So this gives you one story or one picture. Like there is a tool, Redis benchmark, which Redis itself offers, where you can set certain things. So here, like number of requests, and this is basically introducing some randomness. Like if you're just hitting and getting the same key, then that is not really giving you a real life picture, right? Like you need to kind of insert some randomness, some cache misses, etc. So if you do that, like you can see that what this output shows is 72,000 requests per second. But again, like I can't say that, okay, this is the typical output or this is the typical latency, that everything is 99.76 requests are served in less than 1 millisecond, because it will change. It will depend on various factors. How fast is your CPU? What kind of RAM you have? What kind of internet connection you have? Those things will play a role, right? So it is important to not just say that one number, saying that, oh, I can handle 50,000 transactions per second. You can, if you're giving like a lower kind of lowest possible benchmark, saying that, okay, I know I can at least handle this much, and then I can do further optimizations to improve my performance even more. So for example, like some network bandwidth, like obviously you don't pick dial-up kind of network, but if you have 1 Gbps versus 10 Gbps, right, it will have impact. But that is also another interesting observation. It will have impact depending on how large is your value that you're returning. Because if you see further down on this document, so this is the throughput per data size. So depending on how much data size, meaning that how much in one query, how much you are requesting back, there is virtually no difference between if you're requesting 100 bytes versus 1000 bytes. And that is mainly because what is your network speed, right? If all of your data could fit in the one network packet, then there is you are basically pretty good on whether you are asking for 100 bytes or 1000 bytes. But if you're asking way more than that, let's say 10 kilo, if your value is 10 kilobytes and all, then your request won't be fulfilled in just one network packet, right? Then you will have to do multiple such packets, and TCP will have its own overhead about acknowledgements and all. So you will see degradation of that. So how much data are we storing? How much, meaning not the overall size of the data, but size of the every key and value. That will have impact on how fast your Redis is operating. So the point is, there is no one single answer that you should typically give. the golden answer is always depends on many factors. And one of the factors is what kind of CPU do you have, what kind of memory do you have, how much data, how is the size of the value that you are returning. Is it fitting in one network packet? Is it multiple? What kind of network do you have? Is it 1 gigabyte per second or is it 10 gigabyte per second? That won't play a role that much if your value is small. If it is only 100 bytes, then you're gonna take the same type. But if you're sending multiple packets, then obviously you will have much different performance on that. Another thing is number of connections, right? How many open connections do I have? Like I think this shows over here. How many open connections can you support? If you have very few open connections, if you have only, let's say, 50 or 100 connections open at a time, you can have significantly high performance. Here we are talking about more than 100,000 requests per second. But if you accept more connections, then as your connections increase, you can see a downward trend in that. So at 30,000, you still have pretty good speed of, let's say, 60,000 requests per second, but that is still half of what you could support with much fewer connection. So there is, I don't know whether I have that slide. I think I do. There is another proxy called 2M proxy. It is spelled as TWEM proxy. I think that was introduced by Twitter. If you have that you could use that either between Memcache or Redis. That one of the things that it does is it reduces the open connections to Redis. So it will have more connections, but it will have fewer connections to Redis, improving the performance even further. So there are multiple different things that you could do. And that is what you should, if the interviewer asks like about performance and all, you can say that, okay, in my experience, I have seen it performing pretty well at 50,000 TPS or even 100,000 TPS, but it will depend on multiple factors, such as what is my network bandwidth, what is the hardware I'm using, even to the level of, am I using a virtual machine or is it a physical machine? Because again, like there is some nanosecond or microsecond latency added if there are virtual instances. And number of parallel connections, size of data that we already discussed. So these are some of the things that the interviewer can ask. The last things, in my opinion, it is less likely for an SDM or TPM candidate that they will be expected to answer these. But from SDEs, it is likely that they will zone in on, okay, what kind of performance we are talking about, and they will see that are you just pulling some number out of thin air, or are you actually giving some justification based on experience? You have seen this, but this for in this controlled environment of, okay, I had this machine and then so on and so forth. So make sure that you're not just jumping into some conclusion and giving some number, but specify some justification. Not to say that SDMs won't be asked these things or TPMs, but in my opinion, the chances are a little low. Like this is probably the differentiating factor between what kind of things you should ask an SDE versus, and even the levels, right? What kind of, how much deeper they dig about what all different factors versus some surface level answer of this should be fine. Actually, let me take a small pause. I saw before I talked about this, operations enabled the poll. So please take a few minutes to answer the questions. I don't see who voted what. I only see 27 of 43 participants voted. If you don't agree with something, I'm okay if you give me a disagree or something, but I would just appreciate if you could also add some qualitative feedback later on what did you not like or what would you like to see it improved. I don't think I'll be taking this lecture again, but I do plan to take some other floaters later. So if you want to see some things change or improve, please add that quality feedback. Otherwise, there is no way for me to know why did you not like this unless you actually state it. If you like something also, it'll be nice if you could state that. That way I would know what to continue doing. That'll be good as well. All right, I think this is one of my last slides. Yeah, okay, so these are the references that I talked about. I think you have most of the references. Before that, let me just briefly talk about Redis and Memcached. Why these two? Again, no specific reason. These are kind of two popular off-the-shelf solutions that you can use. There could be another layer on top of this too, like such as a managed solution like Amazon Elasticache, where Elasticache you can decide whether you want Elasticache on Redis or Elasticache on Memcached. Very honestly speaking, I was trying hard to understand when would I use Memcached. there are not that many good reasons. There still could be some of the reasons, and based on the data that you see over here, I can make a case for one, but Redis is a lot more powerful. Like it offers different data structures, as we saw, not just the key value for like key as a string and value as a string. That's what Memcached does, but Redis does offer you lists and sets and sorted sets and so on. You may not need all of those, but again, having that makes Redis a lot more powerful and usable in many different cases. It also supports snapshots and replication. That is something that Memcached lacks. Transactions, PubSub, geospatial support is also something Redis has, but Memcached doesn't. The key value size limits are also different. Redis has both key and value could be up to 512 megabytes. I don't know when you would use a 502 megabyte size of for the key, for even for value. Just because Redis supports it, I would say don't go. As we saw earlier, right? Like the network latency is one of the key components, and the higher there is a threshold up to which, like the network packet size, where you could not see any difference, but after that you will see a gradual decrease in that. So be very careful in what kind of value you're putting or size you have. For Memcached, the default setting is 250 bytes for the key and 1 megabytes for value. However, there is some documentation which said that you can change the configuration with some commands, but I was not able to find any reference to see how large could the value be. Like by changing the configuration, can you actually make it 1 gigabyte or not? Like I doubt it, but I didn't find a lot of information about that what is the upper limit on that. But out of the box, by default, it supports values up to 1 megabytes. And then the cache eviction policies, as we already saw, Memcached only supports LRU, whereas Redis supports multiple others. Where Memcached has an advantage over Redis is the internal architecture. So Redis is single-threaded. Meaning doesn't mean that it doesn't have other threads. It has other threads to do other things, but the core cache thing of setting and getting, there is only one thread doing that. And what that means, that kind of goes back to what we saw over here, is not just what type of CPU or how much powerful CPU you have, but depending on your architecture, you may want to go with either okay CPU, okay speed CPU with multiple cores versus fewer cores but stronger or more cache and equivalent or less speed. Because if your application is going to be single threaded, adding multiple cores would make no difference or would make very, very less difference. But Memcached being multi-threaded, you can actually scale that vertically, meaning that you can replace the commodity machine with other better machines with more cores, and Memcached will perform better by scaling it vertically. Whereas in Redis, like if you want to scale vertically, you will have to kind of change, not just adding the cores is not going to be enough. You'll have to see cores with larger cache and whatnot. But the primary use case for Redis is horizontal scaling, not exactly vertical scaling. So this is probably the only case where I've found that if your application has this requirement where you may need the dynamic scaling, vertical scaling dynamically at any point, or want to leverage the multi-threaded architecture of Memcached so that you're not just adding multiple servers, but you're actually leveraging the multi-threaded and multiple cores on the CPU to serve the purpose, then I think Memcached would probably make more sense. There are other advantages also, which are less transparent to the user, such as because Memcached does not support all these things, it is very light, meaning that the overhead of the Memcache itself is pretty low, meaning that it obviously has more memory freed on that machine to do other stuff and whatnot. But again, like considering the hardware is getting cheaper and all, it's also apparently a little easier and simpler to set up than Redis, because again, the more options you have, more configurations you need, and then you have to pick and choose, and you have to fine tune your system to make sure that, oh, if I've selected this and this, they are not kind of affecting each other negatively and whatnot, right? So that you have to spend more time and thought in fine tuning and tuning the options correctly. Whereas in Memcached, if you have very limited options, then again, the chances of confusion or need of kind of deciding, okay, what factor do I need to tune, how, those kind of go down. So if you have very simple application, limited data, no need of persistence, something set up very quickly, and you want to take advantage of multi-threaded architecture, I would say you can use Memcached. But for all other practical purposes, I think Redis works pretty good because it offers very rich sets. Looks like there is a question, Rajdeep asking, multi-threaded speeds up reads but not writes. No, it could speed up write as well, depending on, as long as two different threads and cores are not competing for the same write, right? In the memory, if they are doing writes at different locations, then they could speed up writes as well. So not just reads, but writes too. All right, did I cover everything from here? So yeah, this we talked about benchmark, we talked about. If you go to just Google Redis versus Memcached in AWS documentation, or there are other this thing also, you will find more information if you're interested. The CRDTs, we talked about that, talked about this, talked about this. Proxy policies, talked about that. Data types, kind of briefly talked about that. So yeah, I think that's it. These are the references I talked about. I didn't use shortened URLs mainly because I don't know how you're going to get these slides. If you get this as PDF or like this may not be clickable. So if you are interested, you can look up these links and hopefully you'll know more. But again, these links are if you're interested in understanding how like Redis or certain things are there. Like this is not, I won't say is strictly necessary for system design interview question per se. It is mainly for your knowledge. So depending on how much time you have, system design is very dangerous in that that way, that focused preparation is very tricky because you have so many things, that rabbit holes you could kind of go into to understand more and more. But yeah, if you are interested, if you have some time, you can go through this. But some concepts like CRDTs and all, they could be useful not just for this problem, for others also. So I would definitely encourage you to look at that. And I would also encourage to go through the benchmark, not to see how awesome Redis is, but mainly to understand what different factors affect that. And that would help you also tune your answers, like not just jump onto a number particularly, but and not just for this problem, right? This is applicable for many other things. Like you could see that, okay, if this is the case, I should think about these things before kind of just jumping onto one particular number. Pramod, do you have a question?
Hey, Vinit, thank you for the session. I wanted to know if the same question from the EM point of view, in terms of how would the conversation would be in your experience?
Yeah, so I think pretty much everything that we discussed, except maybe of this level, right? Like whether you're gonna go with CRDT or what are the problem challenges with last write wins, how does CRDT handle that, or these individual things, right? Like why network bandwidth, or how it'll affect, or how would the size of data be like important or play a role in performance. Those things I don't think they will ask EMs and TPMs. However, everything else that we discussed about LRU, how would you potentially implement that, or why would you need sharding, why would you need replication, those things, they are a fair game. In that, maybe the routing thing about different options of how will you getting the data from which shard, maybe surface level answer of I will have multiple shards and consistent hashing would be enough for EMs, but then for SDs, they may go into dig a little deeper on how then the client knows which shard to go from. That may not be needed from engineering manager or TPM. But again, see, the problem here is that I am telling you from my expectations, right? I am an engineering manager, and this is what I would expect from another engineering manager or an SDE. But this is extremely subjective. What the other interviewer is expecting is there is no one standard template that everybody follows. So if you have time, prepare for the worst. But again, you can practically expect little less.
Is there a good read up on that proxy? Like you said, when like the primary is sharded and then it is replicated, but there is a load balancer which handles that. Is there a good read up on?
You can see whether this satisfies your curiosity about the proxy policies. Otherwise, you can look up a little bit about 2M proxy and see whether that kind of helps you. I have included the reference to 2M proxy in my slides later. Let me just check. Yeah, it is there.
Yeah.
So
Thank
you can see if that helps.
Thank you, Vinit. I'm enjoying your sessions.
Sure. Thank you. Thanks for your remarks. All right. Anything else? Do I see anything in Q&A box? Nothing there. All right. I think so. We are done with whatever I wanted to cover today. Any other last minute questions? Otherwise, I can give you 40 minutes back. Okay, Rakesh on the chat saying this was great. Can you do more low-level system design floaters? Rakesh, what do you mean by low-level system design? Okay, thanks, Nikhil. Rakesh, if you can raise your hand and just explain a little bit. Yeah, go ahead.
Yeah, what I meant is for maybe a queue, a distributed queue, and maybe designing a database itself.
I think somebody was going to do distributed queue, and for database, okay, I will see if anybody has already done that or not. Otherwise, I think the next one on my plate was probably e-commerce application, and I can do these sessions. The one challenge I see over there is, as I said, like I'm an engineering manager, and my lens for those applications is slightly different from an SD. So to give, I don't know whether we plan to do separate sessions for EMs and NSDs, whereas or just one common and then kind of highlight differences. But I think I will check with the ops and see what their plan is.
Got it. Thank you.
Welcome. All right, there are some comments in the Q&A. Nikhil is saying, thank you. Thanks, Nikhil. Safiq is asking, what are the products using Memcache and Redis? Any practical example that could differentiate the use case? So by product, you mean not the Elasticache kind of products, right? Like Elasticache offers supports for both, but then ultimately me as a user, what I want to use. I think Redis is a lot more often used. It also came after Memcached. So Memcached started like as a simple cache service. There is no one, even if you look at Amazon, right? Like there are so many different teams and applications which use different type of things. Different teams may use it. Like my team used Redis way more than Memcached. So I don't know whether there's like one product that I can say, okay, this product is using Memcached, whereas others are using Redis. But Redis is way more widely used, at least in my experience. Nikhil is asking, can we cover more domain-specific system design sessions? Nikhil, what do you mean by that? Domain-specific? Can you raise your hand and talk? Yeah, go ahead, Nikhil. Oh, sorry. I think I enabled Aisha. 1 second. Nikhil, I don't see your hand anymore. Okay, yeah, go ahead, Nikhil.
Yeah, so I think I was thinking about the sessions that I've seen so far. I've seen one on, say, Twitter, one on Instagram, one on Uber. Those are very helpful in terms of different types of, I guess, patterns. Could we cover more of those real life examples? Maybe we could cover a shopping cart example, or maybe a recommendation systems example, something like that.
Yeah, I know that is definitely in the works. I'm not the only system design related instructor, so we are kind of load balancing it between ourselves. But yes, those all the things that you mentioned, not specifically shopping cart, but I think general e-commerce application, I think that is on the plate. We don't have a fixed date though, like when we will do that, but that is hopefully in the near future.
Okay, thanks.
Welcome. Ashok, your hand is up. Do you have a question?
Yeah, thanks a lot, Manoj. I mean, very well covered. What I liked about the session was its length and the focus given to the important thing. I'll just what I mean is, I mean, previously there were many sessions, and what used to happen is we used to we spent a lot of time in initial sections. Okay, functional requirement, non-functional requirement, what do's and don'ts of a system design interview. And by the time we came to the meat of the that session, everybody is tired, and those were 5 or 6 hour sessions. In that respect, I like this session a lot. I mean, right focus was given to the important thing, and I would like to have more sessions from you. So, what are your area of interest where you think you like to teach? Maybe we can request IK to arrange few more sessions.
I don't think you can give specific instructor preference to IK. Like, I'm sure other instructors also are like equally or if not more knowledgeable. Probably give the suggestion of changing the format, and then everybody could kind of also maybe follow that. So that would be useful. I mean, this is not my full-time job. So also, well, at this moment, I'm in between jobs, so I'm kind of free. But otherwise, I also have to manage my daily responsibilities with this thing. Area of interest wise, I don't think I have any particular specific thing as such, just, except for what I said. Like, I'm not 100% sure whether the low-level thing I would be the right person to do that. Mainly because my lens is from the engineering manager perspective, whereas there are a lot many low-level details that are more important for SDEs. But I see that I get it that from your perspective, like you are meaning students' perspective, those are also important ones. So I'll bring that up with somebody. But overall, like, yeah, my preference would be staying at a domain level or little simpler low-level things such as cache. Mainly because, again, I don't want to do injustice to you, just present my point of view on what is enough, whereas the SDEs have a lot more complications in those low-level systems.
Thank you.
Pramod, do you have a question?
Yeah, excellent point. I think the pace of the session, I like those. And then, if you're patient enough to see if you want to go deep or not. So that's a very good point by Ashok. The pace, because what happens when these sessions go for 4 or 5, it becomes draining, and then you lose focus, and then you miss some important information, and then you catch up, and you feel guilty to ask the presenter, and then the focus is lost. I like these 2 to 3 hours because anyway, you have to cram down this information in 30-40 minutes. So 2 to 3 hours is about right time. So maybe good feedback to IK. And I'm glad you're able to manage this in 2 to 3 hours.
Cool. No, I'll definitely communicate that, but you could also communicate that to whoever you usually give feedback to. I think I'm sure that they will consider that and act on it. Cool. All right. Well, thanks everyone. Really appreciate your kind remarks and comments, and I hope you all enjoyed this. Wish everybody all the best, and hope to see you all in some other session.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today